Hey guys, welcome to class 4 of your college algebra class. Today we are looking at the next section in chapter 1. So this is going to be section 2 of chapter 1.1. So we're looking at, if you don't have your book, no big deal, but I'm on page 85 and I'm going to walk you through this section 2, which is called Conditional Equations, Identities, and Contradictions. And so what we're doing, this is actually very, very similar to what we looked at last week, where we are looking at linear equations. However, these linear equations, the way that they come out may not always be equal to a number answer. And so it may be what's called an identity or a contradiction. So let me show you what I mean. I'm going to walk you guys through on page 85. And again, if you don't have your book, no big deal, because I'm going to walk you guys through these exact 3 questions in example 4. So these are going to look very, very similar. Letter A says this. It says, well, I don't even know what that is. That's a 3. That's 3 times 2x minus 1, and then is equal to 2 times 3x minus 2. Okay. So it looks very, very similar to what we saw last week, where we do have a linear equation and we're trying to solve for x. So what we're going to do, again, the idea first, just as we did last class, we want to remove those parentheses, and we do so by using the distributive property. So I'm going to distribute the 3 to the 2x and to the 1. So 3 times 2x we know is 6x, and 3 times negative 1 would be negative 3, or we'll write that as minus 3. Then over on the other side, we're going to do the same thing. 2 times 3x is 6x. And then 2 times negative 2 would be negative 4. Okay, so maybe you can already see where this is going. What's going to end up happening is just like we did in, if not, I'm going to show you. What we're going to do is just like we did last week, I want to move my variable to one side of the equation. So I'm going to subtract my 6x from the right side and do the same thing over on the left, which happens to be the exact same thing. So since they're canceling out over on the right side, because they're the same on the left, they also cancel out over there, which leaves me with the answer negative 3 is equal to negative 4. And we know that negative 3 is not equal to negative 4. They are two completely different numbers. So therefore, this is what is called a contradiction. It's called a contradiction, and the way that I think about it and why it's referred to as a contradiction is because one side contradicts the other, with one side being negative 3, the other side being negative 4. Whenever you get one number is equal to another, this is what's called a contradiction. So what's going to happen on next week's quiz, all you guys are going to have to do is answer that as contradiction. So you'll just have to write in the word contradiction. And even if you got to the point where we were up here, where you saw that the variables were the same, so you know that they're going to end up canceling each other out, you can even stop that in your work right there. You can stop at that point because, again, your answer is just contradiction. So if you want to look at it that way, that's totally fine. And like I said, that's how I look at it, is that one side contradicts the other, and that's why it's called that. On your Alex homework, you will be given 3 choices. You'll either be given the choice no solution. Let's see where x, the other choice is, and these little bubbles are just what you're checking. X is equal to some number, or all real numbers. All real numbers. Well, if I could do this. All real numbers. I'll just write. There we go. Your answer on this one would be no solution on your Alex homework. No solution. That is because the fact that if we were to sub in any number for x, 6 times, let's say we said x is equal to 2. Well, either way, 6 times x would be 12, and 12 they'd cancel out and they would still get negative 3 is equal to negative 4. So no real solution in this one. So that's how you would answer that on your Alex. But like I said, on next week, you'll just write in the word contradiction. And that's like I said, an easy way to kind of think about that because one side contradicts the other. Let me give you now letter B. Letter B in your text says this. Says 3 times 2x minus 1, so it starts out very similarly to the last problem, is equal to, now this time, 2 times 3x minus 2, but plus 1 added here on the end. So to solve this, we're going to do the exact same thing. I want to remove those parentheses, so I'm going to apply the distributive property. 3 times 2x we know is 6x, and 3 times negative 1 is negative 3. So very similar to the last one. Very similar on the last one. I'm going to take 2 times 3x, which is 6x. 3 times negative 2 would be negative, I'm sorry, 2 times negative 2 would be negative 4. And then don't forget this plus 1 over here, so we'll bring that down right there. So our next step is always to combine like terms. In the last problem, we did not have any like terms to combine. In this one we do, because over here we've got two numbers that I can put together. So I'm going to leave the left side as is, since there's no numbers to combine over there. But over on the right, I can combine the negative 4 plus 1, which is negative 3. And maybe you can already see that both sides are the same. If I were to continue to move forward, if I moved my variable to one side, subtracting the 6x from the right and subtracting the 6x from the left, then I would see that they both cancel each other out, and I'm left with negative 3 is equal to negative 3. So still they are the same. If I wanted to cancel out one, oops, I meant to hit the different color. If I wanted to then cancel the 3 from one side and do the same to both sides, I would add 3 to both sides, and I would end up with the answer 0 is equal to 0 when those cancel out. So even if, whether you stopped here when you realized both sides were the same, or here, or even here, it doesn't matter. This is what's called an identity. This is called an identity because I always think of it as like a mirror. That one side, it's like looking in the mirror, you see it on the other side, and that's the identity, that one side is the same as the other. So this one on your Alex homework is the all real numbers answer. That means that no matter what we substitute in for x, no matter what number it is, it will always come out to be 0 is equal to 0 because both sides represent one another. They're the exact same on either side. So therefore, it's the identity. So that's what I mean by that. So like I said, on Alex, that is what's called all real numbers. Our solutions is what it will have you check. But on next week's quiz, you would just write in the word identity. So that's the difference here. Again, we're looking at the difference of contradiction, and that's what we saw for letter A in the previous question that we just did. That's what that was. This one was what's called an identity, so that was because one side is equal to the other, so we simply just would write in the word identity. And so you guys probably see where I'm going with this one. Letter C is going to be what's called a conditional equation, and a conditional equation is actually what we've been looking at the entire time. A conditional equation is what we looked at last week, where our answer comes out to be x is equal to something. So let me go ahead and show you what I mean by that. So this is simply going to be a refresher from last week. So letter C says this. Letter C says 3 times 2x minus 1 once again is equal to, the other side says 5x minus 4. Alright, so once again, I'm going to have to remove those parentheses by applying the distributive property. So I'm going to take 3 times 2x again to get 6x. 3 times negative 1 is negative 3. And then 5x, there's no parentheses on the other side, so no distributive property to use over there. And then there's also no like terms to combine. So it looks like on both sides, on the left, I have a variable and a number with 6x and 3. And then on the right, I have 5x and 4. So once again, I have a variable and a number, so nothing that are like terms that I can combine. So now it's a matter of moving my variable from one side to the other. So I'm going to subtract 5x from the right so that it cancels out and it will remove x from that side. But remember, whatever I do on one side, I'm going to do to the other. So I'm going to do the same thing over on the left. And 6x minus 5x is 1x, which is the same thing as just x. So I'm left with on the left x minus 3 is equal to negative 4 over on the right. So in order to completely solve for x, I'm going to have to remove the 3 I want to get x is equal to something. That's the idea of what we're trying to do in all of these problems. It just, in the first two, we weren't able to. But in this one, it looks like we're going to be able to, because I can add 3 to that left side of the equation to cancel that out and leave me with x, exactly what I want. I just need to make sure I do the same thing to the other side. Negative 4 plus 3 is negative 1. So I get my answer is equal to negative 1. And again, this is what's called a conditional equation. Excuse me. So on your all's questions next week, like I said, you're simply going to be either writing in the word contradiction, identity, or conditional, but it's going to say in the directions, if your answer is a conditional equation, please state what x is equal to. And so in this case, you would write in conditional, and then x is equal to negative 1. So as simple as that, and that's all we're doing. And all of these problems is you're really treating them all the same. You're trying to solve for x, except x may be equal to where we can't do that. So all real numbers or no solution. So let's try another one. I'm going to do some more practice problems. I'm going to do 3 more. And I'm doing 3 more because, once again, we're seeing kind of the same idea. One's a conditional, one's an identity, one's a contradiction, and so on. So let's take a look at this one. This one's out of the back of your book. I am looking at, or the back of this section, number 41, says this. Says negative, and then in parentheses, 6 minus 2w, and is equal to 4 times w plus 1, and parentheses minus 2w minus 10. So we're going to have some like terms over there. So in both cases, our first step is to go ahead and remove those parentheses. So let's apply the distributive property. On the first, over there on the left side of the equation, negative is outside the parentheses, so that we can look at that as if it says negative 1, and that is what's being distributed. So negative 1 times 6 would be negative 6. And negative 1 times negative 2 would be positive 2. Whoop, write that a little bit bigger, 2w. Okay. Over on the other side, we want to do the same thing. 4 times w is 4w. And 4 times positive 1 would be positive 4. And then I still have this minus 2w minus 10. Okay, now our next step we know is to combine like terms. On the left side, I have 2 very unlike terms that I cannot put together just yet, so I'm going to leave those alone. But on the other side, I do have some like terms I can put together. I do have 2 variables. I have a 4w and then a negative 2w, so that looks like 4 minus 2w is a way we can look at that. Whether it's 4 minus 2w or 4 plus negative 2w, I still get 2w, a positive 2w from that. What I can also see on this is I'm going to have some other like terms. I have a positive 4 and a negative 10, which would give me negative 6. So let me get my red pen back here. So that's minus 6. Maybe you guys can already see it. You can see that both sides are already the same. And they are the same even though we have negative 6 plus 2w on the left. 2w minus 6 on the right, remember, is the same thing using our integer rules as 2w plus negative 6. And so really we're seeing negative 6 and 2w on both sides. So you could already stop here and say, okay, they're both the same on both sides, so that we know is called an identity. And so you would just write, oh, if you guys see my horrible spelling there. Why did I write D? I don't know. Identity. So you could go ahead and write that in your answer and go ahead and move forward. If you weren't quite, at that point where you could see that just yet, remember our next step is always the same. We want to remove our variable from one side so it cancels out, but we need to do the same thing to the other, and we're going to see that it cancels out over on the other side, and we would have seen then that we were left with negative 6 is equal to negative 6, still representing an identity. If removing those from both of those sides, you would have gotten down to see that 0 is equal to 0. Therefore, an identity. So all we're doing on that question is writing in the word identity as our answer. Okay, taking a look at another one. Okay, let's see. This one is number 39 from the back of that section there in section 2. It says 2x minus 3 on the left is equal to 4 times x minus 1 minus 1 minus 2x. Okay, so let's take a look at this. So over there on the left, no parentheses to remove, no like terms to combine. So I'm going to go ahead and just leave that side alone, and let's focus on the right. The right side, we do have some parentheses, so we are going to have to distribute that 4. 4 times x is 4x, and 4 times negative 1 is negative 4. And then we still have the negative 1 and the minus, or the, yeah, minus 1 minus 2x. So, again, since 2x minus 3 are two unlike terms, I can't put those together, but I do have a few like terms to put together on that right side. Once again, I do see a 4x minus 2x. I can put together my variables, so I'm going to go ahead and do so. 4 minus 2 I know would be then 2x. So, you can see the variables are the same on both sides. But let's see what happens when we put together our other like terms. I have negative 4 minus 1. Negative 4 minus 1 is negative 5, or minus 5, because that's the same thing as negative 4 minus 1 or negative 4 plus negative 1, if that's an easier way to look at that. So you may be already able to see that this is going to be what's called a contradiction, and we would just simply write in the word contradiction as our answer, if you already see that. If not, same idea. We want to remove one variable from one side to cancel it out, but we need to do the same thing on the other side, and we see since it's the same, it too will cancel out, leaving us with the answer negative 3 is equal to negative 5. Since negative 3 is definitely not equal to negative 5, that is what makes this a contradiction. One side will simply just contradict the other. Okay, and you guys can just stop there. The last one I want to show you guys again know where this is going. It's the other type of problem. Very similar to what we did in last week's lecture. Remember what happens when we come across fractions. If I have the problem 1/2 x plus 3 is equal to 1/4 x plus 1. We want to go ahead and solve this. Remember, because 1/2 and 1/4 can both be turned into decimals, yes, you very well could turn that into 0.5 and 0.25 respectively there. But I'm going to go ahead and use the fraction method. I'll show you guys the decimal method in just a second if you guys would rather do that. But what we're going to do later in today's lecture is going to involve needing to know how to apply these fractions again. So I'm going to go ahead and work with that. So if we worked with, again, our denominators currently are 2 and 4. So with 2 and 4, we want to find a common multiple between those two numbers. So once again, I'm just going to briefly look at a multiplication table of 4 and 2. So 4 times 1 I know is 4, 4 times 2 I know is 8, 4 times 3 is 12. Let's look at 2. 2 times 1 is 2, 2 times 2 is 4. Okay, so I've already found it. I know that I'm going to use 4. We always want to use the smallest of the denominators that they have in common. So that's what we're using there. It's going to be 4. So what that means, once again, is I'm going to be able to multiply both sides by that common denominator. As long as I do it to one side, if I do it to the other, I still keep this equal. Now, we do see now a problem where we have to apply the distributive property, and I always like to write it completely out so I can see that I'm not going to miss anything. So I'm going to write out this distribution. So 4 times 1/2 x is what we're doing first. 4 times 1/2 x. So looking at that individually is going to help us to see how we can cancel out that denominator. But don't forget, 4 also has to be multiplied by 3. We know 4 times 3 is going to be 12. So I'll go ahead and write that down. We have to do the same thing on the other side, 4 times 1/4 x. So I'm going to write that down so we can see how that denominator is going to cancel out. But don't forget, 4 also has to be distributed to the 1. 4 times 1 I know is 4. So I'm going to write that as is. Now, with those the distributions that we're looking at right here with the 4 times the 1/2 and the 4 times the 1/4, this is where those will be able to cancel out. Remember, both, it's like when you're multiplying fractions, you can eliminate these denominators, and that's based on this 4 that we're multiplying it by. In that first problem right here, 4 and 1/2, or 4 multiplied by 1/2, I should say. Since both 2 and 4 can both be divided by 2, That allows me to eliminate that 2 since it's becoming 1 by taking 2 divided by 2. 4 divided by 2 is 2 though, so we do want to have something there, but that cancels out that the bottom number. And so that would leave me with 2 times 1x, which we know would just be 2x then. So we have 2x plus 12 over here on the left. On the right, once again, we need to look at both of these two numbers the same way. 4 and 4, since they're the same number, they will actually cancel each other out. And that is because I'm looking to see what they can both be divided by. 4 and 4 can both be divided by 4, making them both become 1. And so 1 times 1x is simply just x. So then on the right side we're left with x plus 4. So now we're left with a linear equation where both sides no longer have parentheses and no longer have like terms that I can combine on that side. So we need to start moving things around. So I'm going to get this variable from over here on the right and I'm going to move it to the left. So I subtract it from the right and that will cancel it out. Do the same thing to keep it equal. I do the same thing over on the other side. 2x minus 1x is just 1x, which we know is just 1x is the same thing as just x. So I'm left with x plus 12 is equal to 4, but since I need to get x by itself, I'm going to subtract the 12 in order to cancel that out to get x by itself then, but I need to do the same thing to both sides. So therefore I will be left with x is equal to negative 8. And that's where that answer comes in. So this one, once again, you all would write in the word conditional. So I'm going to eliminate some of the space here. So you guys would simply just write in on your answer the word conditional. Conditional there. And it does say in the directions that if you do have a conditional answer, tell me what x is equal to, so you can just write comma negative 8 as your answer on next week's test. And that will be marked correct, and that's how the quiz will look for that. So I hope that helps with that, guys. Those are, again, like I said, looking to see whether or not they are conditional equations, identities, or contradictions. Okay, guys, now let's take a look at what is called rational equations. These are very, very, very similar to what we learned last week with those fractions. So there's just the previous problem we did with those fractions where we had to have a common denominator. So let me explain. So in that last problem, we took a look at, how we had, and in fact, I can't remember what the last problem is now. Sorry, I paused it and then I'm recording this later. I think my last problem, was 1/2 x. And then, so I said that, that's a possibility. You could just turn that into 0.5x. And then we had 1/4 x in that. And I said, that's a possibility. You could just turn that into 0.25x. And that would have worked the same way. But the advantage of knowing common denominators is definitely going to be helpful in these rational equations. These rational equations look something like this. If I have, I want to start off with kind of a real simple one. Let's say I have something like this. I have, and this is one that's in your book in the example. If I have 12 over x is equal to 6 over 2x plus 3. So here, a little bit different than when I had actual fractions. It'd be one thing if it was just 1 over 2. I could probably turn that into a decimal. Or, and then 1 over 4, we said that the common denominator between 2 and 4 was 4. And so that wasn't too bad. But when I have a problem like this, now I need to find the common denominator between x and 2x. So you guys are thinking, well, how the heck do I do that? This is actually a lot easier than it looks. Because the common denominator in all of these rational equations will always be the bigger one of the two. And here's why. So because x is in both of those, 2x just means 2 times this number, which makes it a multiple of x. Let me explain that a little bit further. Let's say I'm looking for multiples of x. Okay, so I'm looking at a multiplication table. I could do the same thing with 2x, but let me show why that's easier by just looking at x. Well, x times 1 would be 1 times x, which would just be x. Well, x times 2, since I don't know what x is, I can't solve this. So we would simply just call that 2x. So there it is. There's the same number we're looking at here. So therefore, 2x is our common denominator. If I were to even look at the common multiples of 2x, well, 2x times 1 is just that. So again, there it is. 2x times 2 would be 4x, and 2x times 3 would be 6x, and so on and so forth. But again, all we're going to see here in most of these rational equations will always be the bigger one of the two. And I'll do some more example problems to show you guys what I mean by that. Okay, so with that being said, if 2x is our common denominator, again, here's why this is going to be a little bit easier than you think. That means, very similar to what we did on the previous problem, that means I can multiply both sides of this equation by 2x. Again, as long as I'm doing it to both sides, I'm keeping it equal. So what's going to happen here? Don't forget 2x, we don't really have to distribute over here because 12 over x is just the one number that's over there. But 2x has to be distributed to both sides over here. So looking at just this 2x times 12 over x, since x is in both the denominator and that numerator, just as they've done before, what that does, x and x will cancel out, leaving me with 2 times 12. Therefore, this right here is just 24. Then that's equal to what we'll do over on the other side. So 2, I'm distributing the 2 times the 6 over 2x over on the other side. So let me just write that out so you can see that clearer here. 6 over 2x multiplied by that 2x. Well, what's going to happen is since 2x and 2x are the same and they're opposite numerator denominator there, they will simply just cancel one another out, meaning that we're simply just left with the 6, and that makes that 6 right there. So that's it. But don't forget, 2x does need to be distributed to that 3. I think a lot of people oftentimes forget that, so that's where our variable is going to stay. 2x times 3 would be 6x. So then we're left with 6x as well. Now we have a pretty basic linear equation, and I can go ahead and continue this problem and solve that. When I subtract 6 from both sides, that's going to cancel out those 6's over there and leave me with 18 is equal to 6x. And then I want to divide by 6. Sorry, I'm running out of room here. Divide by 6 on both sides, and that will leave me with x is equal to 3. So see what I mean when we're trying to do these? These are, again, very similar in that we're needing to find a common denominator. But since x can't be multiplied by anything, we might think, oh, that's kind of tough. But really, it's just going to be one of those already existing denominators, as it normally is. But it just has a variable inside of it now. Let me give you a different one that has 3 denominators, but I want to show you how it's just as easy. So this one is actually from the back of this section, the review questions back there. I have 1/2, okay, that's a normal looking fraction, minus 7 over 2y is equal to 5 over y. So once again, we're dealing with denominators that have variables in it. So now we have 3 different denominators. But if you can see, they've got one that the other 2 also share. We have 2, 2y, and y. The bigger one of the 2 also includes, if you can see, 2y has a 2 in it, and 2y has this y in it. So therefore, 2y is going to be your common denominator. Yes, I very well could look at all of the multiples of 2, y, and 2y, and you would see that, 2 obviously is 2, 4, 6, 8, and so on. But y times 1 would be y, times 2 would be 2y. And so because 2 is a number, it very much can just, it's considered, 2 times y is 2y, so 2 is included, if that makes sense. So 2y and 2y share a common denominator of 2y. So that's going to be our common denominator there. Okay, so what that means, just like we did on the last problem, I can multiply both sides of this equation by that 2y. So I'm going to do it to both sides in order to keep it equal. So what that allows me to do, and I'm going to go ahead and write the distribution as I always do. If you guys can do it a lot faster by just leaving it as is, that's fine. Just don't forget to multiply the 2y by both the 1/2 and the 7 over 2y. Oftentimes people do one and forget the other. So I'm just going to write it out. 2y times 1/2. Oh, that's a 2. Sorry, that's a terrible looking 2. And then minus, and then the other one is 2y times, sorry, my iPad is just not cooperating with me today, over 2y is equal to 2y times 5 over y. Okay, so again, each of these we're going to be able to cancel out that denominator, so let's go ahead and do so. Since in this first one, I'm looking at this first one over here, since 2y and 2 are opposite numerator denominators over here, they both include that 2, so therefore the 2 gets canceled out. But the y stays, so y times 1 makes this y. In this next one, the second equation here, the second part of this equation, I should say, 2y times 7 over 2y. Since 2y is included in both the numerator and the denominator, both 2y's cancel out. Since they're the same, that means I'm left with then minus 7. The 7 remains. And that last one, so 2y times 5 over y, since y is included in both that numerator denominator, y gets canceled out, leaving me with 2 times 5, which is 10. So then I'm left with a normal looking linear equation that says y minus 7 is equal to 10. Well, we know how to solve that. I'm just going to add 7 to both sides to get y is equal to 17. And it's just as simple as that. So hopefully that's kind of a refresher to you in that, it's very similar to what we did in the last couple sections when we were dealing with fractions and we had to have a common denominator. And this is very, very, very similar. It just allows us to, just as we've done before, move those denominators out of the way, as they can sometimes just get in the way. But of your denominators, it's always going to be the larger of those denominators, the one that includes your other numbers. And that's a way to kind of think about that, especially when we're dealing with those that have variables in it. Alright guys, last thing I want to show you guys in this lecture is section 4, looking at solving literal equations for a specified variable. So this is going to be real short and sweet. There's a couple different ways you'll be able to write these answers, and I will accept a couple different ones, and let me show you what I mean. So what we're looking at is anytime you're given any type of linear equation with multiple variables in it, I just want to see how you would rewrite it if we wanted to just get one of those variables by itself instead of the current one. So for instance, let me show you this one. This is what's called the distance formula. It means distance is equal to rate multiplied by time. Not that you have to know that. It's just showing you guys there's a linear equation on here with 3 variables. D is equal to R times T. If I told you guys that using this linear equation, how I would write that is I would give you this linear equation and then say to solve for R. What that means is I want R by itself instead of D, like it is right now. So how would I get R by itself instead? Well, let's think about just how I normally look at different variables. Right now, R is currently being multiplied by T. So I would simply just get R by itself, since it's currently being multiplied by T, I would simply just divide by T. And I'll divide by T on both sides, making sure I keep it equal. That will cancel out the T over there on the right and leave me with D divided by T. Since they're both variables, I cannot do anything with them. I can't completely solve that. So that means I am left with R by itself is equal to D divided by T. And so that would be the answer. I simply just want to know how I would rearrange that linear equation in order to get it to where one variable is by itself instead of the other. Let me give you guys another one. Sometimes you may have some problems where there are some numbers involved as well. If let's say I had, and these are the examples from your book, if let's say I had 3x plus 2y is equal to 6, and I want to solve for y. That's how this will be worded on your all's quiz. That means I want to get y by itself. Right now it's sharing that same side of the equal sign with the 3x and the 2. Well, again, in any equation, anytime I want to get one specific variable by itself, I want to get rid of whatever's being added or subtracted. That 3x is currently being added, so I'm going to subtract it. That will cancel it out over here and leave me with 2y, so that therefore the only thing I have left to get rid of is the 2. But remember, whatever I do on one side, I've got to do the other. 6 and 3x cannot be combined, so I can't do anything with those, so that leaves me with either 6 minus 3x, or if you wrote that as negative 3x plus 6, that would be totally fine as well. As that is kind of the common way. Some people put the variable first, and that is just equivalent, doesn't matter. Okay, last thing I want to get rid of is that 2, again, because 2 is being multiplied, I need to divide it, and I need to divide it on both sides. So that cancels it out over here and leaves me exactly what I want, y by itself. Now, on the other side, you guys can do a couple things. You can either leave that as is, and I will accept that. You could look at 6 divided by 2 on its own. So 2, when you're dividing both of those numbers, 6 and 3x, dividing them both by 2, technically that's the same thing as 6 over 2 minus 3x over 2. And that's the same thing as well, meaning that you could reduce 6 over 2. Well, 6 divided by 2 is 3, so you could call that. But then 3x divided by 2, I can't really reduce that, so you could call that then 3x over 2. So this would be completely reduced because 6 divided by 2 can work. But don't forget 3x is also being divided by 2, so that would have to be written as well. But like I said, I'm okay with you guys leaving it as just 6 minus 3x over 2, and that would be fine because that means you rearranged it correctly. Either way, I want to see the y by itself. So y is equal to either 6 minus 3x over 2 or 3 minus 3x over 2. Okay, and there's other answers too. If you did put your variable first, it would have been y is equal to negative 3 over 2x plus 3. And that would have been fine too. It would have been just this flipped, and that is totally fine. Like I said, there's going to be multiple answers for a couple of these, and that's what I'm looking for there. In your book, they have it, looks like they have it as both ways. They have it as negative 3x plus 6 over 2, or what I just wrote, negative 3 over 2x plus 3, where they reduce the 6 over 2. Does not matter either way. Like I said, as long as you are getting that on its own, that is all I'm looking for. Let's see. So I will do, let's see if I have another one of those. I'm going to grab one from your book here. So let's say, where are these in your text? Okay, so let's say I want to do one kind of similar. Let's say we have 5x minus 4y is equal to 2, and I want to solve for y again. This is one in your book I've just grabbed, and that is number 75 in the review section on page 93. So just the same as what we've done before, so that's separate from the equation. The idea is to get y by itself, so y we see is being multiplied by that negative 4, we can look at that as minus 4, or subtracted by the 5x. So since 5x is in there, if you want to go ahead and remove it from that side, what you can do is if you subtract 5x, that's going to cancel that out there, and we will be able to move it to the other side, and that will leave me with negative 4y. So notice I didn't do anything to that negative. That's why I subtracted that 5x. So that will leave me with that. If you did choose to add that 5x, that would have then left you with 4y instead, and it would have been plus 5x on the other side. And that would we're going to end up getting the same thing. So we have negative 4y is equal to 2 minus 5x. And then so what we'll have to do to completely solve, I'll have to divide by that negative 4. And that will leave me with, and they've gone ahead, it looks like they've reduced that 2 over 4 to 1/2. So they have that as y is equal to, and they put the variable first. So they have 5 over x, since it's the negative and the negative kind of cancel out. I'm trying to think of a better way to explain that. Because when you take this whole thing, you're dividing by that whole thing by -4, you can almost separate that as 2 over -4 minus 5x over -4, if that helps. And then you can see what happens is you can reduce that 2 over 4 to 1/2, and that's what they did. To completely solve that, that's what they've that's what they've done, is they've reduced that, so we get y is equal to -1/2, and then they actually have that as plus 5 over 4x, and that is because the negative and the negative canceled out over here. So that is the completed answer. But again, as long as you've rearranged that, if you left it as 2 minus 5x over -4, that would be totally fine, because my goal is just to see that you've rearranged the equation, and that is just perfect. So I hope that helps. You'll have some more example problems in the review video for that. But that is all I wanted to cover with you guys today. So remember to go back through those, the conditional, contradiction, identity problems, as well as the rational equations, and then these where you're solving, you're taking linear equations and solving for a specified variable. If you guys have any questions at all, let me know.